All right, we're going to look at our log rules, and we're going to look at how to use these to expand and condense logarithms. So the first one that we're going to look at looks like this. It's actually, if we add two logs together that look like this, that have the same base. So in this case, my base isn't stated. So if I don't state it, it's base 10. And so we call this guy the common log. We haven't talked about him too much yet, but this is the common log. If I don't write the 10, it's the same thing as writing the 10. So this and this are the same thing. So if you see that, just know that the base here is a 10. Okay, so if I have log m plus log n, this is actually going to be the same thing as this one, multiplying the m and the n inside the same log. Now let's look at why this is true. So we're not going to do a proof or anything, but we're going to do a convince yourself. I call it a convince yourself. I'm going to use some numbers that I know and see how this turns out. So I'm going to use log base 2 because that's a little one and it's easy to do, and we all know a lot of our 2's. So let's look at this one. So if you remember, this expression says the exponent that you have to raise 2 to get a 4. The exponent you have to raise 2 to get a 4. So 2 to the what is equal to 4, and this little expression is equal to our question mark, remember? So this guy is actually a 2. You agree with me? All right, now this guy says, the exponent you have to raise 2 to get an 8. And what do you have to raise 2 to get an 8? Well, that's a 3. Or in other words, we could have thought about it as log base 2 of 2 squared plus log base 2 of 2 to the third. And obviously we know this one is a 2 and this one is a 3. Okay? Now, if I look at this side and I write it as log 4 times 8, well, that's the same thing as log of, base 2, I'm sorry, of 2 squared times 2 to the third, isn't it? Because this is 8 and this is 4. Well, if I think about it that way, it's easy to see that this is going to be log 2 of 2 to the 5th. So really, what did I do? I added these exponents, didn't I? And so now we know that it's going to be that value, 5. Well, if I added these exponents, and this is the value of those exponents that I have to raise 2 to get, 2 to the 5th, and over here, I just did it separately. Found the 2, and then I found the 3, and I added them afterwards. Of course, they're both going to come out to be the same thing. So in this case, it is, whether you add them before or after, it doesn't really make any difference. If I think about them as two separate logs being added together, or I think about these numbers inside being multiplied together first, which means I'm going to add the exponents, I'm going to get the same value. Okay? So that's our first rule. And of course, I can write it the other way. The other way would also be true, because that's the nature of equality, right? We could also go from having them multiplied together on the inside to writing them as an addition. Okay? So that's our first one. Let's look at the next one. And the next one is along the same lines, but this one says that log of m minus log n is actually equal to log of m over n. So if I combine them together, and on the inside, we can actually divide them. And again, let's look at why this is true with some numbers to make it easier for our brain to understand it. If I make this one log base 2 of 4, and this one log base 2 of 8, hopefully you can see that once again, what number would this have to be? Well, that's log base 2 of 2 squared minus log base 2 of 2 to the third. So what exponent do I have to raise 2 to get 2 squared? 2. What exponent do I have to raise 2 to get 2 to the third? 3. This is a 2 minus 3, which will give me a negative 1. Let's look at this side. If I just use my rule and I stick these on top of each other on the inside, so instead I call it log base 2 4 over 8, well, this is log base 2 of 2 squared over 2 to the third. And everybody knows that when I divide, I'm really subtracting the exponents. We usually would write it like this, right? We'd write it as 1/2 because this would be, you'd have a 2 on the bottom. And of course, how do you rewrite that with an exponent? This would be log base 2 to 2 to the negative 1. So what do I have to raise 2 to get 2 to the negative 1? Negative 1. So you can see here that if I subtract them as separate logs, or I subtract the exponents first and then find the log, you're actually doing the same thing. You're basically subtracting the exponents, right? So either way, since these are the values of the exponent, and in here you're going to subtract the values of the exponents, you're going to get the same value, no matter which way you do it. All right, now the last one that we really have to look at is this one. If I have log base m raised to the n, I could actually do that as n log base m. Now this one may seem like doesn't make sense, but let's take a look. If I have log base 2 of 4 to the third, okay, I could think about that as log base 2 of 4 times 4 times 4. Is that true? Sure. I could say log base 2 of 2 squared times 2 squared times 2 squared. That would be true. All right. And then let's take a look. That would be log base 2 of 2 plus 2 plus 2. So 2, 4, 6 of 2 to the 6th. So this one would be a 6 because what do I have to raise 2 to get 2 to the 6th? 6. All right. Now let's think about it the other way. I could also think about it if you just use the rule that we just learned a second ago. I could actually even break this one apart. I could think about this one as log base 2 of 4 plus log base 2 of 4 plus log base 2 of 4, which is what? 1, 2, 3 of these. So you know how multiplication works. If I have multiplication and I'm adding 3 of the same thing together, that's the same as multiplying that value by 3. So this would be 3 log base 2 of 4, which is actually what we just set up here. It's like taking this and putting it down here. So take a look at this one. If I move this guy down here, it would be 3 log base 2 of 4. And again, what's log base 2 of 4? Well, what do I have to raise 2 to get 4? That would be a 2 times 3 would give me my 6 that we just said it was. So there's lots of ways to look at this one, but basically what we're doing is we're taking this value, we're finding out what his exponent would be, and then we're multiplying it by this exponent, just like we did here, right? We took this exponent and we multiplied them together, or these bases, and we multiplied these exponents together, so we added them. When you multiply things with the same base, you add the exponents. Or again, if you had thought about it as log base 2 of 2 squared to the third, maybe that's even easier to see. You can see that this is going to be log base 2 of 2 to the 6th. So there's a ton of ways to look at that one, but they all end up with the same conclusion. So what are the 3 conclusions that we came up with? We said log base m of n is equal to log base m plus log n. And again, it doesn't matter what the base is here. I just left it as 10, but it could be any base as long as the bases are the same. The bases do have to be the same, though. You can't have a base 2 and a base 4. They have to be the same base. Log base m over n means we subtract them. And log base m to the n means that we multiply them together. So this would be n log m. So those are our 3 log rules that we're going to be using. And actually, I'll show you in the next video how to simplify them. Or use them, I guess, to expand and condense.